Hello and welcome to Earthquake Tip number 32. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through these 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing buildings and structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 32 is on why is quality critical in earthquake resistant buildings. It is important to understand that quality is critical for ensuring safety of buildings during earthquakes, and therefore appropriate measures are required to control qualities in all activities related to earthquake resistant design and construction of buildings. If it is not done, the weakest link of building will fail. It doesn't mean that quality control is not important for buildings meant to resist effects other than those meant to resist earthquake shaking. But there is a difference. Let me explain this. For example, the building meant to resist gravity load are designed to resist loads much higher, let's say about 2 to 3 times more than the gravity load that may arise during lifetime of building. And hence, no damage occurs in building with minor structural deficiencies in individual members because of availability of adequate margin in design. Thus, some errors can be tolerated in design or workmanship without serious consequences or getting noticed. On the other hand, buildings meant to resist earthquake effects are designed for later earthquake loads much smaller, say up to about 10 times smaller than what may be experienced during earthquake shaking. If the building were to sustain no damage during severe earthquake shaking, it is because earthquakes occur rarely. Hence, ordinary buildings are expected to undergo damage during strong shaking, and therefore every structural element is expected to respond in a certain way and is tested to its limit when strong shaking is experienced. That means deficiencies in structural elements can result in premature, unwanted, or unwarranted failures because there is no margin. Effects of poor quality are clearly noticed. The negative consequences of poor quality are most visible during severe shaking. To conclude, therefore, quality is far more important in buildings exposed to earthquake effects than in those exposed only to other load effects, that is, gravity loads. Having explained quality and earthquake safety, now let's understand what is quality control. Quality control means adopting and ensuring formal procedures and processes that are based on scientific principles and professionally agreed terms. The need to ensure quality arises at every step of building development process. Let me explain you these steps one by one through these slides. First is conceptualizing structural configuration. Architects and structural engineers need to work together to adopt a good configuration. Designing the structure. Structural engineers need to take utmost care while performing required calculations as per sound structural safety concepts and relevant design standards. Next is preparing structural drawings. Structural engineers and draftsmen need to comprehensively and accurately present structural design intent in well-detailed drawings. Fourth is selecting construction materials. Contractors need to take utmost care in selecting the intended construction materials and adopting construction procedures as per standard specification. Next is converting structural drawings at site. Competent site engineers need to faithfully follow structural drawings to ensure that the design intent is actually realized in the building, working with certified artisans as per good construction practices laid down in standards and specification. And the last is undertaking post-construction activities. Maintenance engineers need to embed long-term maintenance steps like preventing leaks, thereby avoiding structural damage in post-construction handling of structures and preventing damage to buildings, especially to critical structural members. There is another important aspect other than quality control, which is quality assurance. Let's understand what is quality assurance. Rigorous independent monitoring and correction need to be undertaken by competent third-party professionals or professional agencies which are other than those involved in quality control efforts, so as to ensure that the design intent is actually realized in buildings. This is known as quality assurance and is required in each of the steps or activities just explained to you before. Now let's understand how this quality can be ensured. Quality must be ensured by all stakeholders involved in building delivery process, including architects, structural engineers, draftsmen, contractors, site engineers, artisans, that is barbenders, carpenters, and masons, and maintenance engineers. Each activity needs to adhere to pre-specified procedure laid down in design codes and standards. There is no single activities that is more important than the others, which alone determines the quality of the building being built. For instance, just designing the building for a higher seismic lateral force to compensate the quality in construction will not ensure a safe building. Even if one of the key stakeholders fails to deliver quality, overall earthquake safety of building may be endangered. Building owners need to seek professional services that comply with what is shown in this slide. Proper understanding and estimation of earthquake hazard at the site, rigorous design, compliance with prevalent standards, specification and bylaws, independent design review, that is peer review, procurement of intended quality materials, careful construction of the building, independent construction audit, and approved occupancy and use of buildings. Any shortfall in understanding or implementing any of these aspects need to comply in safety of life and property in the building during earthquake shaking. It is also important to note that services of competent professionals, that is architects and engineers, are essential to incorporate these aspects in buildings. These professionals need to have past experience of having successfully provided such services. Now let's understand the challenges in earthquake resistant design and construction by building owners through this slide. First challenge is identifying competent architects and design engineers. There are many standards and specifications for earthquake resistant design and construction of buildings, which architects and design engineers need to be conversant with. The mandatory curricula in architectural and engineering colleges often do not ensure that the required background is provided to graduates. Thus, it is unlikely that all architects and engineers practicing today understand earthquake behavior of structures and the design techniques required to incorporate earthquake resistance in them. So building owners face a challenge related to selecting competent professionals to undertake earthquake resistant design of their buildings. Government need to establish robust systems for identifying competence-based licensing of engineers, which could assist building owners. Next is complying with building codes and municipal controls. Local governments require architects and design engineers to ensure safety of buildings through faithful compliance with various building codes and municipal bylaws. This cannot happen only on the basis of voluntary efforts by professionals. It is the responsibility of municipal authorities as well to enforce compliance. But a severe shortage of suitably, adequately trained personnel in municipal offices can be a bottleneck for ensuring compliance on part of local governments. Alternate strategies are required to build a robust system for enforcement of earthquake safety, that is independent peer review by consulting engineers of good standing. Third is understanding earthquake hazard estimation studies. Seismic hazard assessment must consider many uncertainties. For ordinary buildings, it is best to adopt seismic design codes of the country, but for the projects of importance, site-specific studies are required, for which owners will require services of competent earthquake geologists, seismologists, earthquake geotechnical engineers, and seismic structural engineers. Faithfully converting construction drawings of buildings into actual structures is also very critical for ensuring earthquake safety of buildings, and therefore competent contractors must be appointed by building owners to implement formal construction strategies and construct earthquake resistant buildings. Quality control needs to be exercised at all stages of construction by the contractors. However, independent agency needs to test quality of all construction materials before accepting them. Similarly, independent competent engineers deployed for site supervision need to examine that work is being done as intended. These independent engineers employed for site inspection needs to have requisite competence. Therefore, competence-based licensing of construction engineers and certification of artisans are very essential. Before we end up, let's talk about professional ethics, which needs to be observed by all of us. Earthquake-resistant design and construction is possible only with high ethical standards employed by all personnel involved. A project can be successfully executed only by avoiding these three types of errors: error of intention, error of concept, error of execution. Error of intention is really an issue of ethics, while error of concept and execution are of competence. For instance, a professional accepting an assignment beyond one's competence is indulging in unethical practice. Similarly, a professional realizes that one is unable to follow correct procedures and still proceeds with the project is an unethical practice. And finally, an engineer not allowing code provisions to reduce structural cost indulges in unethical practice. In all civil constructions, society takes performance of a structure for granted. For instance, one drives over a bridge unconsciously, assuming it is safe. Hence, it is critically important to ensure and enforce high level of ethical standards in the practice of engineering. It is not possible to legislate virtues, but the situation can be elevated to some extent by putting in place systems and procedures. For example, competence-based licensing, wherein license to practice is given only after establishing that the person has at least a minimum set of skills required to practice design and construction, which may be revoked in case of malpractice, and a robust regulatory legal system with a rigorous enforcement protocol and implementation mechanism that allows for swift penalties and punishments to erring individuals. Such systems may have been effective in many countries, but must be established in countries like India. This is all about earthquake tip number 32. You can download this earthquake tip from www.bmtpc.org. With this, we come to the end of learning earthquake design and construction through these 32 earthquake tips. I sincerely hope that you will try to implement the concepts, principles, and procedures, including guidelines explained through these tips, and help create earthquake resilient building and infrastructure. Thank you.